Jon and I have worked together for more than 15 years now. Jon does experiments to measure thermal properties, and my group does complementary atomistic simulations with an overall goal of trying to link atomic structure to thermal conductivity. So the ability to make inexpensive, low-weight, electrically insulating, and yet thermally conductive plastics has potential use in a lot of different applications, including thermal management of electronics. And so everyone has had a hot laptop or a hot cell phone. Heat is a big problem in many industrial and commercial applications, and the ability to remove it is really important. Particularly in gear that we carry or in vehicles, the fact that polymers are much less dense than metals has a lot of potential advantages. So our objective is to develop plastics that can transmit heat as well as metals, that is polymers with high thermal conductivity. Polymers are very long molecules that assemble in a disordered manner like a plate of cooked spaghetti, and this disorder leads to them having low thermal conductivity. We are trying to align the polymer molecules like the spaghetti in a box, as this is a feature that is known to lead to higher thermal conductivities.
In addition to thermal management, there is a subset of polymers known as frameworks that are highly porous, and they can be used for gas storage and chemical separations. But these chemical processes release heat when they happen. And if you have polymers with low thermal conductivity, that heat creates high temperatures that damage the system. So we want high thermal conductivity polymers that remove the heat without creating high temperatures. Another thing that I'll note is polymers are such an important material set because they are much easier to manufacture than metals. And another focal point of our work is polymers that can be chemically recycled so that we can have a sustainable future. So I think these are naturally going to appear in products that we carry and use all the time and get hot, like our cell phones and our laptops. But they're also going to appear in industrial products and applications, for example, in the electronics used for radar systems in the communications industry.
And there are also exciting applications in textiles and fabrics, for example, clothing, where the flexible nature of polymers makes them much more amenable than using, say, a stiff metal. And these could be used to regulate temperature of your body on a cold day or even on a hot day.
So because we're actually developing new polymers and processing of those polymers, it's likely that they would only be used in niche industrial applications within the next decade, but as those take off, perhaps within the next 20 years, you could see them in consumer products more widespread.